axis layer. Alright, in the layer 3 axis layer or rotated axis layer switch, okay, here you can see that now we have MLS in the axis layer. Okay, in the right picture you can see that we have MLS. Because of that, we can convert the interfaces of the switch to the layer 3. Actually, now we have full layer 3 capability or full layer 3 routing between the access and also distribution. Actually, here now the access layer switch is the boundary between the layer 2 and also layer 3 domain. Here you can see that layer 2, we have layer 2 access layer. This is STP based, but here we have layer 3 access layer. This is the for example layer 3 access layer. Also, let me to emphasize that when you use the layer 3 access layer, we don't need to configure any first hop redundancy protocol. Actually, FHRP is not available here because the boundary of the layer 3 is the access layer switch. Actually, the access layer switch has the complete capability of layer 3 routing. Actually, the default gateway should be configured on the access layer switch. Because of that, here first hop redundancy protocol does not require. After that, here we don't have STP. We don't need STP because you know that here we have multiple links. All of these links are layer 3 links. Because of that, here we don't have any layer 2 loop. Because of that, we don't have actually STP, and it means that all links now are forwarding, and we can use the more bandwidth that here we have. Because of that, we can say in the layer 3 access layer method, okay, we have the more bandwidth. Actually, this method increase the uplink utilization. After that, the troubleshooting is easier. You know that here we can use ping and traceroute and some other features that we have in iOS for troubleshooting. Actually, from the access layer switch, you can use ping command. You can verify the paths directly from the access layer switch then to distribution layer switch and to other devices, because here we all of these links are layer 3. And also here we have faster convergence. You know that STP does not have the, for example, fast convergence time. You need to use RSTP or rapid STP. But because between the layer 3 access layer switch and also the distribution switch, we have layer 3 links, we can use, for example, EIGRP or Enhanced Interior Gateway Routing Protocol, and also OSPF, Open Shortest Path First for routing. Because of that, we will experience the faster convergence time. Actually, it means that the network will be faster. Okay, this is the layer 3 access layers benefits. But here also we have some disadvantage. For example, you know that now the VLAN 10 should be located only in one switch. Actually, you cannot use VLAN 10 in this switch and also in other switch. Actually, in your network, if you want to spread the VLAN 10 between different switch, you cannot use the option of layer 3 access layer. Also, the implementation of this method has, for example, a higher cost. You know that here we need to use MLS switch in the access layer. Because of that, we need to pay more. Because of that, this is another disadvantage of the layer 3 access layer. You know that until now we learned about the two-tier design, actually two-tier or collapsed core, and after that 3-tier, and after that we learn about the layer 2 access layer STP base and layer 3 access layer routed access. Okay, you know that you can combine these methods together for the design of enterprise network architecture. Let me to explain the next feature, the next method that we have for enterprise network architecture. We call it simplified campus design. In simplified campus design, we use switch clustering features. For example, you know about the virtual switching system or VSS, or stacking technologies such as StackWise. In these technologies, we can convert multiple physical switch to a logical switch. Okay, you learned about them in previous courses. Because of that, actually here, as you can see, now we have a network include 2 access layer switch, okay, and 2 distribution layer switch. As you can see, we can use the VSS or virtual switching system to convert these 2 physical switch to 1 logical switch. And after that, as you can see, now we have 2 link between this access layer switch and also this VSS. Because of that, we can use Ether channel technologies or aggregation technologies. Now we have layer 2 or layer 3 multi-chassis Ether channel, okay, as you can see here and also here. And after that, if you have the option of using the stack-wise technology, you can stack-wise these 2 access switch together. Again, now we have the option of the aggregating all of the interfaces with each other, and now we have a higher bandwidth link between them. Look at here, in the first scenario, okay, in the first physical layout, you can see that the 2 distribution switch converted to 1 logical switch with VSS technology, okay. You can use only VSS. If you use only VSS, and after that here you can see, because now between this access switch and this VSS, we have 2 link. We can aggregate these 2 layer 2 or layer 3 links together. We will have multi-chassis Ether channel, one here and another here. Okay, this picture. But if you can do the stack wise or do stack this 2 access layer switch also to each other, for example here, actually now we have 2 logical switch. The first logical switch created by the VSS technology between the distribution switch, and also the next logical switch created with the stack wise technology, okay, between the access layer switch. And now actually all of these 4 links connected to 2 logical switch. Because of that, again here you have the option of the layer 2 or layer 3 multi-chassis Ether channel. Also, let me to say that using this design approach across all the campus blocks, okay, when possible, can provide an optimized architecture that is easy to manage, resilient, and also more flexible with higher aggregated uplink bandwidth capacity. Here you can see that we use the simplified campus design. Actually, we stack the access layer switch here, and after that the distribution switch here aggregated with the VSS technology. And after that, we aggregated the links between these 2 layers, and now we have a simplified actually design. Also, as you can see, in the other places in the network, again now we are using the VSS or stacking technology. For example, between these 2 distribution layers switch, now we use VSS, and also here VSS and then VSS. And actually, as you can see, now we can aggregate all of these links. And here we have multiple benefits. One of the benefits is using a simplified design. With simplified design, actually you need to manage only single logical distribution layer, and it means that you need to waste for example less time to configure, to manage, to troubleshoot this network. It reduces the amount of time spent on ongoing provisioning and maintenance. Actually, with this simplified campus design, as you can see, we don't need to configure first hop redundancy protocol for like the HSRP, like the VRP, because the IP gateway or default IP gateway is residing only on single logical interface. For example, interface VLAN 1 of this VSS, interface VLAN 1 of this VSS, or other interfaces. Actually, here the 2 physical switches are converted to 1 logical switch, and in this 1 logical switch we have only 1 interface VLAN. Okay, after that, the other benefit is that we can say reduced STP dependence. As you can see here, we don't have any loop and we don't need to use STP, and because of that our dependence to the STP now is reduced. And actually we can use Ether channel, and you know that when you use Ether channel, actually you eliminate the need to the STP, and it is one of the benefits of the simplified campus design. After that, as you can see here, we have increased uplink utilization because we can aggregate all of the links, okay, to each other. We don't have any block link, and because of that we can say that increased uplink utilization is one of the benefits of this the network design. And after that, about the easier troubleshooting, you learn about the benefits of the troubleshooting that here we have. For example, you know that because the topology of the network from the distribution layer to the access layer is logically a hub and spoke topology, this reduces the complexity of the design and troubleshooting. And then faster convergence.